Good morning, good afternoon, good evening, everybody, and welcome to our webcast on enabling safe and secure platforms for advanced graphics and compute. I'm Mark Tootle. I'm the Regional Sales Manager here at SYSGO for UK, US, Canada, and Australia. I'm joined by Dr. Oliver Coulert and Robert Pickles, who will be presenting today. I'd like to hand over to Oliver. Oliver, over to you, sir, if you'd like to introduce yourself and start presenting.
Hello and good afternoon. My name is Oliver Coulert. I'm working at the technical marketing at SYSGO. And this afternoon, I want to talk about CoreAVI and SYSGO's graphical solutions on top of the PikeOS hypervisor. The seminar will start with a short company introduction, followed by a quick view into current marketing trends. We will talk about safety and especially safety rendering. There will be a short excursion on security topics. We will showcase a little bit our development environment. And finally, we are going to talk about certifications. So let's talk about SYSGO. So SYSGO has been founded in 1991 and has started as a company around embedded development, especially Linux and hard real-time. We soon started our own little Linux distribution called AVIONICS, which turned into a well-known and well-suited product. We also started distributing operating systems from the US for the safety market and gathered a lot of experience in certification regarding safety. And by doing so, we at around 2003 started our own operating system, which is suited for the embedded market and has been used in a couple of certification projects since. Our flag product is the PikeOS operating system. It is a hypervisor which directly runs on a hardware, so-called Type 1 hypervisor, and it uses virtualization techniques to run multiple operating system, guest operating systems on top of it. It also features hard real-time and uses a very, very small microkernel, which is only about 30,000 lines of code, which is pretty small compared to a full-blown Linux kernel. Our product is ITAR-free, which means there are no export restrictions in the European and overseas markets. Let's have a quick look into current market trends. So, of course, there is a real growth in autonomous devices. This is especially true for automotive, even in tandem with electric cars. So the whole drivetrain is being updated and autonomous driving is being discussed. This is also true for drones and even in the railway market. And coming with this, the certification need has expanded. So usually a customer will set up a whole complete big project containing the hypervisor, graphics, and so on. And we provide certifiable components at every level of the system. So from CoreAVI comes the graphics component, from SYSGO comes the certifiable file system, certifiable IP stack, and the operating system itself. Other trends are regarding hardware. So even the smallest or smaller embedded chips have become multi-core. So multi-core is a big issue. And in addition to that, for example, considering the Xilinx ultra-scale boards, there are heterogeneous cores on a chip, so even with MNU and with MPU at the same time, and also containing a lot of built-in hardware to control I/O, etc. In addition to that, the software basis has expanded, and even in safety market, a lot of open source is being used to increase the features. So in this case, we are heavily talking about mixed criticality, and in addition to that, you might want to use a hypervisor to separate the different licenses you're using on a system. Let's talk about safety. So our operating system, PikeOS, has been primarily designed for the avionics market when it came out. So at this point of time, IMA was the thing which nowadays can no longer be ignored on the airplane market. So even all the bigger airplanes use IMA integrated modular avionics systems. The IMA standard is mostly driven by ARINC 653, which both features the configuration as well as the API. In addition to the standard ARINC 653 system, PikeOS has a lot of enhancement when it comes to time partitioning, priorities, and extended resource partitioning. In addition to that, PikeOS provides an ARINC 664 standard, which is also known as AFDX. When it comes to automotive, the advanced driver assistance systems are in the focus currently. We can provide a complete AUTOSAR adaptive platform. When it comes to connectivity, almost every car today has a connectivity to some kind of wireless GSM standard, 5G, 4G, and 3G. In order to protect the car interiors, you usually need some kind of enhanced gateways. And also, the number of ECUs in a modern car needs to be reduced in order to have less wiring, less weight. This can be done by means of virtualization, which allows to consolidate multiple applications, operating systems, and runtime OSs on one hardware board. Also, the certification issue is an issue here, so we're talking about the according ISO compliance. Other markets where PikeOS is well seated is the space market, the railway market. When it comes to railway, PikeOS was the first operating system which had a certified SIL4 multi-core support. We are also supporting industrial automation as well as the medical market. Talking about real-time aspects when it comes to safety with PikeOS. So PikeOS is a FIFO scheduler with 256 priority as well, running on fixed time slices. This can be configured in a smart configuration systems where you can have high priority interrupts being handled in user space as well as fixed time slices. The PikeOS operating system has a complete preemptive design, which means that you can preempt any running thread even when it's in the kernel. We are using fine-grained logging in the kernel. That means that we have almost no interference on multi-core systems. On the OS level, we also support resource partitioning, time partitioning, and when it comes to cache partitioning, we also can lock partitions or use color partitioning to decrease the interference between cores. There is a relatively new position paper coming from the avionics industry called CAS32A, and with PikeOS you can build systems which are completely CAS32 compatible. Here's an example about an architecture where you're running two cores with critical and non-critical partitions at the same time. And below you can see an example how to set up your architecture so that you can guarantee that you have no interference when you're running the critical partitions at the same time, while you can have high features non-critical partitions running on both cores at the same time. Talking about safe rendering, PikeOS can use the Vulkan API, which runs as a kernel driver and fully runs a GPU in virtualized mode, which means that a lower level application cannot disturb a DAL A application running on the same system. There are multiple use cases to set this up, and my colleague Bob Pickles from CoreAVI will go more in detail on this later. Talking about real-life examples, so our software is running in the Loadmaster workstation of the Airbus R400M. That is basically a console which is in the rear of the plane and controls the cargo area as well as the dock bay door at the aft of the plane. We had multiple applications there at multi-criticality levels running on top of PikeOS at the same time on the R400M. Beyond that, PikeOS can run multiple operating systems on top of it. For example, a POSIX environment, which is fully certifiable. Of course, the ARINC runtime environment, which is also called the APIX API. We can run a full feature Linux on top of PikeOS. Of course, our in-house AVIONICS is the first choice, but in addition to that, you could also run a Debian or even a Ubuntu Linux on top of it, or any embedded Linux. Actually, you can run a Linux in two modes. The first one is a para-virtualized mode, where you need an adapted kernel, but you can also run fully hardware virtualized, where you can use a Linux kernel unmodified. We are using this, for example, in case of Android. We also had a project where a Windows was running on top of PikeOS. We also have ADA and can port any legacy operating system on top of PikeOS if required. In terms of development, we are using Codio. It is an Eclipse-based IDE. And in addition to the most obvious things like syntax highlighting, project management, we also provide target analysis like static analysis and system tracing. The system tracing gives you an insight on what is happening on the system on both kernel level as well as application level. In addition to built-in traces, you can also add your own traces. And of course, fully featured remote debugging, remote deploying is included. The Codio environment is both available for Linux and Windows hosts. About security. So this is the PikeOS architecture. You can see the microkernel, which consists of the kernel itself, a architecture support package, and the platform support package, which implements the board-specific parts. The so-called PikeOS system software is the first software which is being started by the kernel and completely runs in user mode. This one sets up the static partitioning and then starts any guest operating system. To give you a rough figure, the microkernel is about 30,000 lines of code, the system software 11,000 lines of code, and the Linux kernel here is about roughly 30 million lines of code. The guest operating systems and PikeOS native or certifiable operating APIs depends on its nature, and usually we are talking here about 10 to 15,000 lines of code when it's a certification relevant operating system. So in a traditional monolithic systems, you would have 30,000 lines of code here, and a typical attack path would go over a vulnerability of an application and the kernel, and then you would have full control over the entire system. In terms of PikeOS, you can actually isolate a running Linux kernel to its partition, and we can guarantee there is absolutely no interaction between the Linux kernel and the real-time and security-critical applications apart from wanted communication channels. Even if you have no known vulnerabilities, you can still penetrate a system. This can be, for example, done by stressing the CPU with a high volume of demand or stressing the memory system with complex requests. In both cases, any safety or controlling function of a monolithic system would totally fail. So how can we make sure that the functionality is still kept alive? For example, communication and control of a drone. Well, with the PikeOS time partitioning, you can assign static time slices to the Linux operating system and have static time slices to the real-time and security and safety partitions, making sure that there is absolutely no contention coming from the Linux kernel, which might be completely out of order because of the denial of service access, but this does not contribute over to any of the real-time operating partitions. When it comes to memory, the same can be guaranteed because the memory which has been assigned to the Linux partition has been statically assigned and allocated at system software startup. And even if all those memory is being used up at the start of the operating system, there is no contention to the other operating system. This is even true for the memory which is being used by the kernel to actually handle and manage the partitions. So even if there is a high volume and complex demand, even on the kernel side, there is no contention to the other because even the memory which is used by the kernel itself is partitioned. Coming to certification, so we have a long list of certified standards, starting with the AVIONICS. This is DO178B and C, of course, so we can certify the kernel up to the level Del A. On industry automation, we have SIL 4 and SIL 3 certification artifacts. For the railway, we go up to SIL 4. So there is a relatively new standard which has not been listed here and is applicable for rolling stock, and we completely certify this standard as well. And on the automotive market, we are actually supporting ASIL D. Almost all of our engineers have worked in certification projects recently, so we have a long experience on that one, and we have a long list of certification customers. When it comes to what is actually being certified, so we have the system software and the PikeOS kernel, as well as the architectural ISP package, which have been pre-certified. And there is a relatively short list of pre-certified BSPs because we only do this on demand. But this is only about a very small line of code, and we can very quickly certify any board that you would need. In addition to that, our certified RPAs and runtime environments are also available for state of certification issues. On the avionics market, the primary document is the DO178C, and one of the primary issues here is the traceability. So when it comes to documentation, the requirement documents and the testing documents are available for PikeOS. When it comes to requirement numbers, everything can be included in your overall system architecture, making the traceability complete and visible to any certification authority. Regarding the V model, for every step of the development, we have the related tools, and in our ecosystems, we have a partner for every part of the system. For example, CoreAVI when it comes to graphics, Lauterbach when it comes to hardware debugging and code coverage. With PikeOS 5.0, all our configuration tools have been validated so that you can do the verification and validation of the code on source code level, and no longer the configuration binaries need to be examined when it comes to certification. The certification kits which are available are for avionics. We have D, C, and B certification kits. For railway and automation, we have SIL 4 and SIL 2. For security, we are certified according to common criteria EL3+. And we also have a certifiable IP stack and a certifiable file stack. And what is relatively new and comes with our next release is the certifiable MAF library. As a conclusion, PikeOS is a hypervisor and real-time operating system for safety and security. It is intended for usage in avionics, automotive, space, railway, industrial, automotive, medical. And in tandem with CoreAVI's Vulkan API, it supports resource and time partition mechanism and is excellently suited for safe rendering and compute. PikeOS is also ready for multi-core processors. That's from my side, and now I will hand over to my colleague Bob Pickles, who will go deeper inside CoreAVI and safe rendering on top of PikeOS.
Thank you, Oliver. So my name is Robert Pickles, or Bob Pickles. I'm a senior FE for CoreAVI. I'm going to be talking about advanced graphics and compute on top of safe and secure platforms. So the first thing we do is look at the introduction to CoreAVI, look at some market trends, Then look at Vulkan SC. So Vulkan SC is Vulkan Safe Certifiable. So Vulkan's a brand new graphics library that CoreAVI are making certifiable. Look at it, Compositing, Compute, collaboration with SYSGO. So look at some projects and other items we collaborate on. And then look at the ARM partnership. So let's introduce you to CoreAVI. So CoreAVI started with a mother company called Channel One in 2005 in the UK. They were dealing with embedded GPUs, in fact ATI GPUs, providing component obsolescence for other systems in the industry. By around about 2008, they opened US HQ. 2011 is a key marker in CoreAVI's foundation because Alt Software, which was the primary OpenGL safety certifiable graphics company using AMD GPUs, went into administration, eventually bankruptcy. So Channel One acquired the IP as well as most of the safety certification engineering staff and pulled them into CoreAVI. So we have around about 10 to 25 years of experience with our engineers and safety certification for OpenGL. 2018, we created a new library based on Vulkan, which we're going to talk about later on today. COTS-D is a new project. In 2017, we're designing COTS custom off-the-shelf or commercial off-the-shelf design IP. So the way that works is we have extensive expertise in GPU certification from a hardware and software perspective. We have the essential employees to make the hardware, for example, VPX processor cards, and we also have the capabilities to provide DO254, 178 certification artifacts, which allows a non-experienced company to build that hardware in their own manufacturing plant and use our artifacts to get through the certification process. 2020, we launched a GPU compute library called PikeOS, which we're going to talk about later. As well as that, we have some key partnerships with ARM, AIRBUS, and of course NXP. And SYSGO, of course. We have a number of offices around the world, quite a few CoreAVI offices, and the rest of the international reps cover all of the territories that we don't cover directly. So looking here, we can see that CoreAVI has a very, very experienced profile, especially certification, where we've actually certified 172 safety critical systems already, which has been flown in over 60 aircraft today using CoreAVI solutions. As well as that, we're still working on this year another 42 safety critical systems. That's the level of experience that CoreAVI have in the safety certification marketplace. So this is some of our key partners. Obviously, SYSGO is the key partner today because we're having a webinar, but we also work with a number of others like ARM, Intel, NXP, AMD, and so on. Yeah? As these companies here, ANSYS and Precision and Disti, are providing HMI on top of OpenGL or Vulkan. So if we look at some market trends to work out why GPU and compute is such a big part of the industry these days, embedded vision is one of the key technologies that are used on many, many market verticals, including automotive and aerospace, in fact, using GPU cores to create on-the-fly effects, such as target outline, see-through capabilities. For example, if a helicopter is landing, the pilot can use his helmet-mounted goggles to see through the skin of the aircraft to see below him to safely land the helicopter. So that's using GPUs and camera systems. Windowless aircraft concepts for future air travel, as well as existing projects such as the X-59 Quest, which is a NASA-based project using flyby camera, where the pilot can't actually physically see through the nose of the aircraft or below him. So you have to use a camera system to fly and land, but we're going to talk about that later. And of course, augmentation of displays, special effects, which can include camera sensor-fed display systems using machine learning. Of course, you need GPU cores to enable massive parallel machine learning. So compute has been with us for a very long time. 2004, LLVM.org was created, which is really an open source organization as opposed to open standard. They did the first work which contributed to the next levels of compute called OpenCL, CUDA, and Vulkan. because they were working at a low level, working on all of the devices, and they pioneered the compilation of C code on a host architecture to run on a target GPU architecture. So nowadays, they're still open source. They're used in education platforms, but they're still worth considering for a background in compute. So most SOCs have a GPU already, so that means compute's available to everyone. And of course, Vulkan allows access to both GPU, graphics, and compute in one API. So GPU compute opens up quite a few features, such as massive parallel processing, because you can have 500, 600, 1,000 cores on one GPU. We can run embedded neural networks, artificial intelligence, and machine learning algorithms on the GPU, away from the host machine, because we can use the massive parallel processing capabilities. So we can use this to enable advanced driver assist systems. We can even use it to monitor human fatigue, whether it's driving a car or driving a train or something else. As well as that, we can add features such as night vision, especially in the new models of cars. They're including night vision on windscreens and rear view mirrors, so they can identify objects in the dark very easily. And of course, machine learning for quite a lot of the systems in the car, and obviously systems in avionics now, because I attended a recent show where a lot of companies are using machine learning and having monitors around the machine learning to try to prototype systems of the future on aviation. So what's Vulkan? Vulkan is the next generation graphics and compute API. It's highly efficient, cross-platform, simply because it's been designed for mobile phones all the way up to the highest end GPUs. So it has to run on a phone as fast as it's going to run on the high-end GPU. And so big manufacturers such as Samsung and others like this, they use ARM-type technology, and they want to use the best GPUs for the phones they can. So it's widely used for commercial applications, including high-performance gaming, because the high-performance gaming companies found that OpenGL had reached the end. They couldn't get the performance from the games using OpenGL, so they needed a brand new library to open up modern GPUs to get that performance, which they're now using now. So this is an example of a game that a games company is using now. We can see that most of the GPU providers are moving to Vulkan, including ARM, NVIDIA, Imagination, and AMD, of course. And Vulkan will eventually, given time, of course, replace OpenGL, OpenCL, and CUDA. So it's an ideal platform for next generation machine learning, which is one of the biggest things that's happening at the moment in all industries. But of course, it's not safety certifiable. If you look at the Cronus specification for Vulkan, this is a commercial one. It's not safety certifiable, but that then leads into Vulkan SC and how we make it certifiable. So one of the key points is deterministic resource management. We have to make sure that all the memory is statically allocated, because on the commercial one, this doesn't happen. It's all dynamic. And also we have to make sure that any shaded code is compiled offline on a host and used at startup and downloaded at the very start, so it's static compilation always. Because the Vulkan commercial spec allows dynamic compilation and dynamic download to the GPU, so that's dangerous in a safety certification world. So commercial Vulkan doesn't support OpenGL, but CoreAVI's VkCore SC does support OpenGL SC 1 and 2. These product options are called VkCore GL SC 1, and the typo here, VkCore GL SC 2. We also support GPU safety monitor called TrueCore. If you have a high-level certification display and you want to make sure that the Vulkan or even the OpenGL process of creating the frame buffer is correct before the information is displayed. We also have support for video capture, encode decode, and compositor built into Vulkan SC. And it's certifiable across a wide range of standards. So the spec for Vulkan SC can be found here, but it's not actually produced yet. So this is really a discussion page, but maybe in a few months the specification will be released. But if you need to see the specification, this can be available through NDA, through CoreAVI. So what does it offer? We've already been through some of the packages that VkCore SC offers already. We talked about OpenGL SC 1 and 2, which is vital for a lot of companies that have spent a lot of hours developing source code for OpenGL SC, because if you have to go to Vulkan direct, then it's going to be a lot of software engineering resource time spent on that. So we provided these packages already, They're known as VkCore GL SC 1 and 2. They're an option on top of Vulkan SC. We also provide the Vulkan SC API, which of course allows GPU and graphics at the same time. So you don't have to use the OpenGL SC libraries. You can use the Vulkan graphics library and the Vulkan compute library. So there's two types of compute, shader and kernel compute. We're going to talk about that later on today. We can see TrueCore mentioned already, safety monitor, encode, decode, and of course video capture. So the architecture of the VkCore SC library, we can see at the bottom there, we can see the safety critical Vulkan driver. We can see the application at the top. We can see that there's a direct link from the application to the Vulkan SC API. We can also see there's optional OpenGL libraries on top. We can add a GPU safety monitor on top, and we can also add the video capture, encode, and decode drivers. So you can see the architecture supported. So NXP really means PowerPC and Layerscape type products. That's the PowerPC are the old products, Layerscape's the new products. So the GPUs that we cover at the moment, we cover AMD E9171 GPU, simply because AMD are providing the certification artifacts for the hardware certification of this GPU. So this GPU has 5 DisplayPort outputs. It's got a very high TDP or total design power, but it's meant for high-end graphics. They're actually known as medium-end graphics if you talk to the industrial people, but this is high-end graphics for military applications or aerospace applications. 8 compute units for shader and kernel compute work. We also have the Vivant or support the Vivanta GC7000XS VX, known as Vega. That has the possibility for each GPU to have 2 HDMI displays, around about 1 watt approximately, and 8 shader cores. So it's a much lower power than the AMD, so it depends on the application you want to use, GPU you're going to employ. And that's based on the processor architecture as well that you deploy on your system. So compositing. Compositing is a way to take a number of visual elements from separate sources, as it says there, and compose it into a single image or video frame. We also know this as blending, whereby we take a primary frame buffer, for example, with critical details such as speed, range, until the gas tank's empty, and various warnings, and we mix it with some fancy complex 3D animation layers. So that could be OpenGL ES, and this could be OpenGL SC. So the blending process or the compositing process provides a single display that's not corruptible for the primary graphics part by the secondary graphics part. So it's in full control of the display process. So the compositor implementation for OpenGL is different from VkCore SC because OpenGL relies upon embedded graphics library. So there's a link here. You can look more about this on Kronos. VkCore SC provides compositing as standard out of the box, and that's from CoreAVI. Compute. Compute is quite a complex subject, but we try and break it down into different types of compute. So if you see shader compute, that's really embedded vision and visual effects, and kernel compute, processing algorithms. And of course, embedded vision and machine learning are all about cameras and sensor-based technology to enable the machine learning algorithms to take the sensor-based information and provide an output. Obviously, these have to be trained to create the correct output. And if we look at a modern car, we can see pedestrian avoidance, we can see some night vision assistance, some parking assistance. As well as that, we have some fatigue monitoring and blind stop type intervention capabilities. Most of that is now being used with machine learning and GPUs, of course. So if we look at other offerings from CoreAVI, we're providing Compute Core, which is a library intended for embedded vision. So the PDF we can find on the CoreAVI website down here, but that provides such things as blur filters, contrast filters, gamma correction, as well as fast Fourier transform. And the most important thing is that all Compute Core functions are certifiable to DO178 and also ISO 26262, and many other certification standards on request. One of the projects we already talked about was the X59 Quest, which is a low boom demonstrator. We can see already that the nose is very long, so the pilot can't see below the aircraft or in front of the aircraft. So everything on the aircraft, including the engine and the swept wing, are there to reduce the size of the pressure shock waves. which enables quite supersonic flight. So they reckon by 2022 they're going to fly this test aircraft, and they think they can reduce the supersonic shock waves by about 1,000, bring it down below 70 decibels, which is very nice, especially if you want to fly supersonic in a passenger jet past 2030. So this is the key goal of this project. Of course, part of this is allowing the pilot to fly using cameras. The display in the cockpit is fed entirely by cameras. There's two systems, one to fly normally in the air and one to land the aircraft because there's no vision because of the wings and the nose to land the aircraft. So this is a fully automated fly-by-camera system using our AMD E9171 and Vulkan VkCore SC. And there's more information here. So VkCore SC on PikeOS. Oliver's been through some of this already, but we're going to go through and have a look at this. I'll describe a little bit about PikeOS. So typically, VkCore SC would come as a kernel mode driver, but it could also be running as in, for example, a native partition or an ARINC653 partition in user space mode. We could see there's different applications, ARINC653. We can see there's different libraries, VkCore GLSC, that's OpenGL SC, interfacing to the VkCore SC library. We could also see one partition maybe using some machine learning or embedded vision using Compute Core. And we can also see a Vulkan application directly accessing the VkCore SC library and using the API directly. It could be driving another display using the Vulkan API. And we can also see a native application capturing some video across a PCI interface from an FPGA or maybe even another computer system. So VkCore SC provides multi-partition, multi-core, and the compositive functionality in the library. So that's a big change from the previous architecture we had because that was different options. So this is one library for all these options. So let's talk about collaboration projects between SYSGO and CoreAVI. Across a few markets, we can see an outline of PikeOS again, but I've removed the Vulkan parts or the VkCore SC parts just to show you the types of interface that's available, the partition types on PikeOS, even the Linux, which is the Linux partition, using OpenGL, the number of processors that's supported and the GPUs that are supported on various projects that we've been working with, the types of projects like a ground station, pilot, head-mounted display prototype, as well as demo units of trade shows. We participate with SYSGO quite a lot there. And we have some new projects that are ongoing that we can't talk about at the moment. And of course, NDA doesn't allow us to talk in full about any projects that we're going to show in this presentation. One of the latest collaboration projects that we have with SYSGO is on a COTS-D program. So this is the COTS-D program where we're designing hardware for avionics. So it could be military or aerospace avionics. So we've designed an ARM processor based on LX2160, which has got 16 cores of ARM Cortex-A72. So PikeOS is collaborating with CoreAVI to provide PikeOS and a BSP supporting this COTS-D board. Remember, this is a board whereby we're building this for the industry. We have to build some prototypes because you have to be able to test it with your applications. And then we provide some production boards. And then the customer can then build it in their own manufacturing fabs, and we provide all the artifacts to do that. So we're not really competing with the board providers. We're providing certification experience to customers or board vendors that have no certification experience to build their own white label products using our IP. So this is an overview of the LX2160. We named this the SBC 3003. We can see it's using the NXP LX2160 processor core, and we can see the various I/O. Obviously, most of this wouldn't be used in a real certification system, such as SATA, USB. Someone might want to use 10 gig. Most people want to use 1 gig of Ethernet. Then we can see stuff like RS-232. So one of the things that we do is in the collaboration is that we have a working partnership whereby if you want to look at this product as a COTS-D product to produce in your own manufacturing plant and get the IP design from CoreAVI, you can approach SYSGO or CoreAVI and get the following information. So we have a technical data package, which basically tells you how to build the board, how to manufacture the board, and gives you a training package to do so. Failure mode analysis package, Cert Core 254 is the DO254 artifacts for certification. The same with 178. That'll be for a BSP or even for the Vulkan SC library if it's running on top on a GPU. So there's two different products at the moment, an SBC and the AMD E9171 GPU. As well as that, we provide cert support through the life of the project, the certification life of the project, where it's FAA or EASA. We also provide, or can provide together, the PikeOS board support package, the PSP, if it needs to be modified, the bootloader, which is normally synced to the PSP, and of course PikeOS RTOS and the cert artifacts associated with that PikeOS RTOS. If you want to know more about collaboration, you can see the web link here. You're welcome to visit our site anytime. So we're going to look at how you can actually evaluate PikeOS, because we've talked about PikeOS and of course CoreAVI's VkCore SC. How do you evaluate that on a product without spending lots and lots of money on a VPX system, for example? So what we've come up with CoreAVI is you can actually evaluate Vulkan SC or VkCore SC on Windows and Linux. You can also evaluate it on PikeOS as well. So we have a number of evaluation platforms. We have the NXP MEK, which is based on the AIRBUS. So we can provide that with Windows, Linux, and PikeOS. This one is basically a PCI-based AMD E9171, so you can evaluate that in Linux and Windows and PikeOS as well. We also have the facility using RDB development chassis to evaluate Vulkan SC and PikeOS using PowerPC and Layerscape reference systems, as well as VPX type systems. So we have VPX and XMC cards available as well. So recently ARM announced a new partnership based on the ARM Mali G78AE. AE stands for Automotive Enhanced. So we're a key partner for ARM for safety critical automotive systems, whereby CoreAVI will provide VkCore SC to ARM customers for those safety critical automotive systems. And of course, we're supporting next gen ARM Mali G78E. So the key point about the ARM Mali G78E, apart from it's being automotive enhanced, so that means the artifacts are available, so it's ready, it's capable already to be certified. It also has hardware virtualization and flexible partitioning of memory and by core group, which is very nice for aerospace as well, to enable mitigation of interferences between cores and memory. It's also designed for ISO 26262 and IEC 61508, which is functional safety, up to ASLB, and of course SIL 3 for 61508. So CoreAVI will be providing ASLD for the ARM Mali for automotive applications, and also we'll be looking to provide the DO254178 packages for aerospace for the ARM Mali based products. But of course these are maybe a year and a half away because the IP has just been released by ARM. So it takes a long time to build a system on chip or a processor card with this type of GPU on board. And that's my webinar presentation finished, and it's over to Mark.
I think we've come to the end. So thank you, everyone. That's the end of our webcast. Thank you for joining us, everybody.